Alright guys, today's lesson was on multiplying and dividing powers. So let's fill in our notes and look at some examples. Alright, so the first day we did 9-1, we looked at and we discovered all the rules. So what we're going to do is we're going to concentrate on multiplying and dividing rules today. The first one's called product of powers. Okay, product means multiplying, and then we're dealing with powers and exponents in this unit. All right, the rule says that you can multiply powers that have the same base, okay, the same base by adding their exponents. So that's the rule. All right, so here's an arithmetic example. All right, so see they have the same base. The big bottom number is 4. So we can just add 2 and 3, and that would give us this. There's your answer. All right, now remember you can always expand this out and see what the big picture looks like. 4 squared would look like this, and 4 cubed would look like this, and then count how many 4s you have. 1, 2, 3, 4, 5. But in algebra we look for those shortcuts. So the rule will keep us from having to expand all of it out, but don't forget you can still do that. All right, an algebra example, if we have the base, common base is a, they have to have the same base, we just add their exponents, 3 plus 4, and we would get 7 a's. All right, let's look at the quotient. Quotient means divide. So the rule says that you can divide powers that have the same base. Okay, remember they have to have the same big bottom number, but this time if we're doing quotients, we're going to subtract the exponents. All right, so look, here's your fraction. Remember, division is a fraction. So we have 4 to the 5th on the top in the numerator, and we have 4 squared in the bottom denominator. So we're just going to do 5 minus 2, and we have 4 to the 3rd power. Let's expand that out so you can see the big picture. If there's 4 to the 5th, that means that there are 5 4s on the top, and then 4 squared means there's 2 on the bottom. And what do we know about canceling out? That's going to cancel, that's going to cancel, and there's that understood 1 left on the bottom. So look what we have left. We have 3 4s, and that's the way we write our answer. Same thing with arithmetic. We use it the same way with algebra. So the only difference is we have our big bottom letter is an A. There's 6 of them on the top, 3 on the bottom. Imagine what that looks like when you expand it out and map it out. There'd be 6 on the top, 3 on the bottom. 3 are going to cancel out, and that's going to leave us 3 on the top. Okay, so we just basically do 6 minus 3, and that's where our 3 comes from. All right, we got another rule. It's called the zero exponent. What happens when you have a 0 in the exponent's position? So this will always result in 1. No matter what the base is. So here's the proof. If we have 3 to the 4th power divided by 3 to the 4th power, isn't that the same thing? And when you divide anything by itself, you end up with 1. Yes, but let's look at the picture. 3 to the 4th would be 3 times 3 times 3 times 3. 3 to the 4th on the bottom, 3 times 3 times 3 times 3. And look, they all cancel out. And a lot of people want to say 0. Nope, there's an understood 1 on the top, there's an understood 1 on the bottom right here, and 1 divided by 1 gives you 1. So there's the proof. Now the rule for division is subtract. So 4 minus 4, see how that 3 to the 0? There's the proof. If you have a 0 exponent, your answer is always going to be 1. Even if it was 591 to the 0 power, it's still just going to equal 1. All right, here's the arithmetic, and then here's the algebraic example. So here's 3 A's, 3 A's. They're going to cancel out. There's 1 left over, 1 on the bottom. 1 divided by 1 is 1. Here's the rule. 3 minus 3, you take the top exponent minus the bottom one, you're going to get 0. That just equals 1. All right, last one we have to do is called the negative exponent. So what happens when we have a negative exponent? It's not allowed in algebra. Not allowed. It can be written as a positive exponent by writing the reciprocal and changing the exponent to a positive number. So you just have to flip it. So if you have a negative exponent, you get rid of it by flipping it, and look what happens. It becomes a positive when you flip it. All right, let's look at the picture. 5 to the third is 3 5s up here on the top. 5 to the fifth is 5 5s on the bottom, and notice that these 5s cancel out. So we have that understood 1 on the top, and look what's on the bottom. 2 5s. But the rule says we're supposed to do 3 minus 5, and that is a negative 2. Notice that we just flipped it, and they're both the same. These are both the same, but it's very improper to leave a negative exponent. So we know there's a 1 under it, we flip it, and there's the math magic. It becomes a positive exponent. All right, so let's do the try these. This is the part where you could just stop the video, do these, and then come back in and check. I'm going to go ahead and write the answers in. So while you're pause it, you do it, then come back and check your try these. All right, if you've unpaused the video, here's the answers for A through D. Some people forget to take care of the numbers. You guys have been working with numbers. Sorry about that phone call. All right, so we got numbers. You just go ahead and do numbers like you've always done. 2 times 3 is 6. Okay? Same thing here. Negative 3 times 4 is negative 12, and then you take care of your exponents. All right, go ahead and pause the video again. I'm going to write the answers in. You do the division part, and then come back in and check your answers. All right, if you're back in the video, there's the answers for our exponent division. Don't forget there's other helpful videos in today's folder that might help you if you need some additional help.